going to discuss about the types of insulators. There are 4 types of insulators which I will be explaining now. The first one is pin type insulator. Second one is suspension type insulator. Third one is strain type insulator. Fourth one is shackle type insulator. Now we will be seeing that where are these insulators really placed and what are the advantages of these insulators and what are the mechanical considerations individually and why it is particularly suitable to use in the transmission or distribution system. I will be showing you some insulators which I am having. Majorly I can show you the entire structure of this. So the first type of insulator is pin type insulator. This type of insulator is majorly used in distribution system or transmission system. Now this is suitable for LT type of connection. This insulator should be suitable for LT types of connection. The voltages ranges will be 11 kV or 33 kV. We can say up to 33 kV. So beyond that 33 kV, what happens is the pin type insulator size gets definitely increased. So if the size is increased, the mechanical cost also will be increased, which will be not economical. So what we are going to see in that is what is the construction of the pin type insulator and how it is there. Basically, now I will be showing you exact pin type insulator, how it is going to be, and I'm not going to write the parts on the board. You just remember it, or else you can follow the textbook. Majorly in every place and internet also the parts are available, but I am going to show you exactly what are the parts and how the conductor is placed. So look at this carefully. Now this is an pin type insulator. Okay, this is the pin type insulator, as you can see this. Now inside this you can see here, this is called as cementing. This entire part is called as cementing. This is called as cementing. And now you are having on the top of the insulator pin, you can see this is the top part and this part is called as groove. And in this groove you are going to take your conductor and you are going to place it here. Okay, and after placing this conductor like this, you see, after placing this conductor like this, what we are going to do is we are going to take an annealed wire and we are going to tie this to this conductor so that the conductor doesn't move. Now we will see the galvanized steel pin. Although it is not in a shape of steel, but it will be similar to like this. So we are taking this and we are fixing it in the bottom. You see it here. First you see how it is there. There is a mechanism available like the screw part where you can fix your supporting galvanized steel pin. So what you are going to do is you are going to take this and you are going to fix it inside like this. Okay. Now what they will do is they will now take this insulator along with this galvanized steel pin and they will place on the cross arm. They will fix it on the cross arm. Somehow this will be not on the cross arm, this is not going to be there. On the cross arm you are going to find this kind of nut and bolt system where they will go and fix it on the cross arm. So I hope you have understood this part. So this is the galvanized steel pin where you will fix it. Next part what I would like to say is the topmost part, what you can see here, the topmost part is called as rain sheds or petticoats. Rain sheds or petticoats. Now why it is said like this, you have to understand. When you place the conductor like this, whenever rain falls, it should be very clear that conductor and this supporting pin, whereas this, what happens whenever rain falls onto this conductor, as you know, rain is having water, it is definitely conduct, it is a good conductor of electricity. Whenever the water will come and try and it will hit onto this pin, then there is leakage of current, which is dangerous. So what we do is, they have designed this insulator in such a way that the topmost layer of this, it is visible for you very clearly. The topmost layer of this is little bit big. So that what happens is the bottommost pin of the insulator is safe from the water. That means water comes and hits onto this insulator and that water now goes away from it. So that there is no leakage current from top of the conductor to the bottom of the pin. That means there is no short circuit. And our purpose of the insulator is definitely fulfilled. And these layers, you can denote it as layer 1, layer 2, layer 3, level 1, level 2, level 3. So this levels will be based on the operating voltage. For suppose you are going to operate for 11 kV, okay, then you can take only level 1 insulator. So that is based on the designs, which we are not much concerned about it, but these are the main part. So I will remind you once again, this is groove which is on the top of the insulator where you are going to place your conductor, and there is a annealed wire. You are going to tie this conductor to the insulator, and this part is called as cementing, and this part, uppermost part, is called as rain coating or rain sheds, or else petticoats you can say. Now the bottom of this part, this is galvanized steel pin, which is you're going to fix it on the cross arm. This is the insulator. You can use it up to 33 kV or 11 kV. For the 11 kV, we have one more insulator, LT insulator. This is the insulator. You will mostly find near your homes this kind of insulator for you. See, you are having this again. At this part, there is also a groove. Now you are going to place your conductor like this, as I said you, and with again the help of annealed wire, what you are going to do, you are going to take and tie this onto this supporting chamber so that your conductor doesn't move. This is an LT insulator of 11 kV. You can see it very clearly. Okay. Next, I have covered most of the points, but what I would like to say is, at the pin type insulator, what we have to see is there is no flashover. There should be no flashover. Now, what do you mean by flashover? Now, what do you mean by flashover means if there is formation of arc. If there is a formation of arc between conductor and the supporting pin, this conductor, topmost conductor and the supporting pin, if there is an arc formed here, that is called as flashover. That is definitely flashover. And I would like to even tell one more terminology, that is puncture. Now, what do you mean by puncture? If there is flow of current from conductor to the metal pin, through the body of the insulator, If I take like this, if there is a conductor on the top, if there is flow of current from this top and it is touching the earth part or else metal part, then that is called as puncture. Now this pin type insulator material is made up of porcelain. The material is porcelain material. Okay, next. Now the factor of safety. Factor of safety is equal to 10 for this insulator. That means the factor of safety is equal to puncture strength by flashover voltage. The ratio of puncture strength to the flashover voltage is called as factor of safety. That is given as 10. So if you want to increase the puncture strength or else anything, you can increase the width of this. You can increase the width of this so that the material doesn't allow the flow of current from top to bottom. Okay, before the puncture takes place, flashover occurs. These are the main point for the pin type insulator, what I can tell you. But as it is very clear that you cannot use this pin type insulator beyond 33 kV. This type of insulator is suspension type of insulator. The name itself is denoting that how the suspension type of insulator is going to be. Whenever you see your vehicles, it is definite that you will be having suspension in it, isn't it? Similarly, in case of the insulators also, that is, the structure is going to be like that. Now, whenever the rating of the voltage is greater than 33 kV, now this kind of insulators are used, suspension type of insulators, or else it is equal to 33 kV. Mostly it will be not equal, it is greater than 33 kV means we are going to use definitely the suspension types of insulator. Okay, the logic behind this is the insulator now shape is like this. The insulator shape will now change like this. Now you can observe that this is in form of a disc. This is in form of a disc like this. Okay, now this entire capacity of the insulator is now 11 kV. What is the capacity is now? 11 kV. Now what they do is, with the help of this insulator, what they do is, they will take this 11 kV insulators and they will try to make it in form of suspensions. That means this insulator is taken and it is given onto the top of the cross arms and it is hanged like this. That means this insulator is kept in horizontal position. And what does they do? This will be hanged at the top of the cross arm. Or suppose this is there. This will be hanged at the top of the cross arm. As you can see at the bottom, there is a hook type system. What they do to that hook, what they do, they will take one more disc like this and they will hook it to this like this. That means that will be having a hook at this place. They will make an arrangement of the hook like this and they will place it at this place. They will be taking that hook and they will hang like this and they will hang one more disc like this, so that the 11 kV will be now added to 22 kV. Now to that bottom again they will hang to this part, so that again 22 kV will now become 33 kV, so that whatever may be the rating of the voltage, those many discs will be placed. So I will show you clearly again. Once again you can see this. This is like a bell shaped structure at the top, and at the bottom it is like a hook shaped structure. So this is the insulator 11 kV insulator disc. As these all are suspended from the top of the cross arm, these are called as suspension type insulators. There is no doubt in this. Somewhat will be like this. I am not going for the clear design. Now let us see the advantages of suspension type insulator. Now for suppose, assume that for 33 kV we are going to take a big insulator like this, or else beyond 33 kV we are going to take a big insulator. For suppose there is a flashover on the insulator, that insulator is definitely going to get damaged. Now in order to replace this insulator, the cost is definitely going to increase. That will be a disadvantage for the system again. So the idea behind using this kind of 11 kV discs is, whenever there is a flashover or else some condition or else some damage to the system, what happens is only 1 or 2 discs will be damaged. So that what we can do is, we can go and replace that particular disc only. So it will be an advantage for the system. The remaining discs will be hanging like this. For suppose we are going to take 66 kV. How many discs? 6 discs will be there. Now for 6 discs, what we are going to do? We will see whatever the damaged disc is there. We will remove that disc, particular disc, and we will replace the same 11 kV disc. This will be economical for the system, and this will be definitely advantageous for the system. That is why we are going for the suspension type insulators. Now, as these are placed one below the another, these look like suspensions. This is called a suspension type insulator. These are the basic advantages for using the suspension type insulators. Now, one more type insulator is called as strain type insulator, and there is no doubt that in strain type insulators also this kind of 11 kV disc is only used. But the difference is, now these discs were kept like this in the suspension type, but now in the strain type insulator they will keep the disc like this. Now if I am a cross arm, now I will be holding this disc like this, and there will be one more disc kept to this, and this will be extended like this. That means this disc will be kept vertically. This is definitely kept vertically, and this disc will continue upon the voltage ratings. For suppose it is 66 kV. Now for 66 till 66 kV, 6 discs will be used. But the main advantage of using this strain type of insulators is, wherever the stress is more, this kind of insulators are used. For suppose now there is a turning in the transmission line. There is a turning in the transmission line. That means definitely at the turnings, what happens? Stress is more. Now when you take two edges, if there is a turning like this, what happens? The stress will be more at the sides of the insulators. So this, if you use this insulator disc at the turnings in the towers, that means in the transmission system, then this will be an advantageous. As the strain is more or else the stress is more, wherever the stress or the strain is more, you can use this kind of insulator. Now this is the main type of insulator. And while coming to the conductor material and design, as I have explained in the previous session, you can see that all the mechanical considerations are taken care of. Okay, now this is for the strain type insulator. Now there is one more type of insulator, that is called as shackle type insulators. The shackle type insulators, where you are going to use this, it may be at the starting end or it may be at the terminating end. That means starting end or ending end, or else you can use it at the corners also. For suppose the disc is like that. This is not exactly a shackle type disc, shackle type insulator. What they will do is, they will put two edges like this. For this there will be two edges kept like this with an holding. Okay, what they do is, now to this disc what they do, at the center of the part, it will be somewhat like the shape of dumbbell. So to a dumbbell, you know that at the center part the system is open. To the system, opened system, what they do, they will take and place an conductor. They will now hook this conductor to the tower. For suppose this is a tower or else a pole. What they will do, they will at the starting end, what they will do, they will keep like this and they will tie this conductor to the tower. Now this conductor is now running at the line. Now this may be at the starting end and this may be at the ending end also. Now at the turnings also, you can see if this is if it is having a right angle, for example. Now what they will do, they will take this and they will get this conductor, they will fix it onto this shackle type insulator and they will take at this point. Not only at the starting and ending point only shackle are used, even the strain type insulators are also used at the starting or ending terminals. Why? Because there is lots of stress and strain at the starting, ending as well as turning point. So finally, this entire insulator design part is over. But where you need to keep this conductor at the suspension and strain type insulator, I didn't tell you. So now see here, as I in the suspension type insulator, I said you that these insulators will be kept horizontally and they are in shape of suspensions. Now, where you are going to keep the conductor? That is, definitely you will keep the conductor at the bottom of the insulators. That means these all insulators will be big, the 11 kV disc like this, and your conductor will be running here. So, at the bottom of the insulators, you are going to place your conductor. As well as in the strain type insulator, I have to tell you that the insulator disc will be kept like this and your conductor will be running here. Your conductor will be placed here. So, I hope now everything is clear with this design part. Now, let us take these insulators and keep it on the cross arms and let's see how they are. Pole, put cross arms. Now is the time to place the insulator. Your insulator pins will be kept here like this, and whatever the LT type of insulator is placed, you are going to finally place it on the cross arms. This is how you are going to place. This is your groove. This is your groove. Now your conductor will be running like this, like this. Your conductor will be placed in the groove and it will be running like this. Now next one, at the transmission level, let us take, and in this I would like to tell that this is a pin type 11 kV insulator, LT type insulator. Now you can go and place even the pin type insulator which is having sheds, what I said you in the prior class. Now let us now go for the transmission line. Now take the transmission line, that means transmission tower. Now let us take the transmission tower like this. Now to the transmission tower we are having definitely a cross arm which is fixed like this. Now we will take this insulator. What is this kind of insulator placed? This is definitely suspension type insulators. I am drawing only for the 33 kV. Now this is called as arcing horn and horn gap. I will tell you later about that, but now after having this, your conductor will be running here. So finally we are almost done with the insulators design as well as the mechanical structure as well as the specifications of it. Now we took that insulators and we have finally placed on the cross arms. You can see this. Now your conductor is ready to carry the current. I hope you have understood this class very clearly and you are having no doubts in this.